Hello, it's Yang. Today I'm going to explain how to do a structure analysis in Abaqus. There are 7 main steps that we have to follow in order to carry out the analysis. Firstly, we create the geometry, then we define the material and we assign the properties to the geometry. Then we use the assembly function. This feature only exists in Abaqus. Then we create the load step, then we create the mesh, then we apply the boundary conditions and structure analysis in Abaqus. There are 7 main steps that we have to. So in comparison with other finite element softwares, the method to create the geometry is a little bit different in Abaqus. We create a sketch and then we create the panel. This is quite similar to how solids are created in CATIA. Here we add the dimensions. Now we define the property. Here we are going to define a composite material. We use laminar as it's going to be 2-dimensional orthotropic property. The value of E in direction 1 and 2 are those typical in composite materials. Now here we are using megapascals and millimeters. After defining the property, we assign the property to the material, to the geometry. We make the section symmetric and we define the region of application. We select the material that we have just created. And we define the thickness of each layer. Also, it's important to define the rotation angle with respect to the principal axis. Here, as you can see in the right part of the image, the reference direction 1 is pointing to the x direction, which is what we wanted. After defining the property and assigning it to the geometry, we can make the assembly. Now we create the load step. Now it's time to create the mesh. It's a simple geometry, so the mesh size does not have to be very big or very small. After that, we apply the boundary conditions. Firstly, we apply the shear edge load, whose unit is Newton per millimeter. Now we apply the boundary conditions of fixed end to the three sides of the panel. And on the panel where the force, on the side where the force is applied, we apply the boundary condition which restrains the displacement in the x and the z direction, and also the three rotations. We cannot restrain the direction, the displacement in the direction of the application of the load. So now it's time to define the job. After a few seconds, the calculation step is completed, and now we can view the results. So this is the end of the video. Thank you for watching. Please like the video and subscribe for more contents. See you in the next video.